Hello friends, so today we will just solve a few basic problems and eventually lead to some tricky problems. So this is a very simple problem of Newton's law. A lift is given which is accelerating at acceleration of a and it's coming down. Inside the lift there is a block of mass m. Now it is given that the force exerted by the block on the floor of the lift is mg by 4. Then what is the acceleration of the lift? So it's a very simple problem. The force exerted by the block on the floor of the lift is mg by 4. So ultimately we have been given a block of mass m. So our first target should be to write the Newton's equation for this block. For that we have to make a free body diagram for the block. So what are the ultimate forces acting on it? Of course, the first and foremost one, the gravity, mg, acting downwards. And then there is a surface. So as we know and I have discussed earlier that whenever there is a surface, there must be a contact force. And since nothing has been mentioned about friction, so right now we will ignore friction. So the only contact force left out is the normal force. So this will act in this direction, so a normal force. Now as in the question it's very clearly mentioned that the force exerted by the block on the floor is mg by 4. So applying Newton's third law, the force exerted by the floor of the block on the lift, which ultimately comes out the normal force, should also be equal to mg by 4. So normal will be equal to mg by 4 as per third law, because this was the force exerted by the block on the floor, means this direction. Ultimately it means that the force by the floor on the block will be in opposite direction and of same magnitude, so that is mg by 4. So as this is in contact with the floor of the lift, so whatever the acceleration of the lift is, same should be the acceleration of the block. It means applying F external equals to ma. So F external here is gravity mg and normal is in opposite direction, so minus mg by 4, that is equal to ma. So from here a is equal to 3g by 4. So this is your acceleration of the lift. Simple problem, just simple application of Newton's third law. Now moving ahead. A very typical standard problem which we will face lots of time in solving Newton's law. Suppose there is a fixed wall here in which a rope is tied and that rope passes a pulley. The pulley has somehow been managed at this position, and then this rope comes and connects to the block M. This block is on the floor. So ultimately what will happen? If you are applying a force F on the pulley, then we are moving pulley in this direction. So there must be a motion in the block as well. So it's a typically pulley block rope system. So the previous assumptions which we have made that pulley is light and there should be no friction along the sides of pulley. It means that the tension in the string on both the sides must be same. So if it is T, it should also be T. Had there been no force, then there must not be any tension. As soon as you apply the force, then there will be some kind of elongation in the length of the string, that very minute elongation which here we not have to consider that. So that elongation will eventually leads to tension. So from where the tension comes out, we have already discussed in the previous session. So right now we know that there is a tension, and actually this tension is going to cause motion in this object, because from the picture it's very clearly evident that this force is acting on this pulley. This force is not connected to this block. So what exactly will help this block to move is the tension T. Now, pulley is light. So with help of that, the assumption comes out to be that the net force acting on pulley has to be 0. Always. It means F should be equal to 2T, or T is equal to F by 2. So using this result, we came out to the conclusion that tension is F by 2. Means F acting this direction, so F by 2 in opposite direction. Now, the main tricky part of this question is that suppose this pulley is being pulled to a distance x. Then what will be the displacement of this block, say y? Now, to solve this, the fact which we have to consider is that the length of the string is always constant. The length of the string is not going to change at all. So suppose from here up to this point, this is point O, this is point A, this is point B, and this is point C. Right now I'm rubbing here so that to make it more clear. Yeah. Now suppose in the subsequent figure, pulley moves this much distance and block comes out to be here. This point O, this is the point A dash, A, and this is the point A dash, and here right now is our pulley. So this is the point B dash, and this is the point B, and this is the point C dash. So it means that this is the point C. So CC dash is the actual displacement of this block M, and AA dash is the displacement of the pulley, which we have considering X. So AA dash is equal to BB dash. From picture it's very clear. Now the entire length is constant. This is our basic fundamental here. It means OA plus the circular arc length, if we take AB, plus BC. This is fixed to some length L of the string. In this picture, OA plus AA dash, again that arc length A dash B dash, which will be eventually equal to AB. A dash B dash will be equal to AB because the pulley size is the same, it's the same pulley we are using, so its arc length will be same. The radius is same, so arc length same, that's why A dash B dash is equal to AB. So OA plus AA dash plus Right now, okay, I can write A dash B dash, then B dash B, and then BC dash. This is also equal to L. So AA dash BB dash same. AA dash BB dash. Instead of this, I can write 2x because this is actually equal to x. And instead of A dash B dash, I can write AB. And then I can write B C dash is equal to L. So equating these two, OA and AB plus BC and this part. So equating equation 1 and equation 2, we can write like 2x because OA will cancel out, AB also cancel out. So 2x plus BC dash equals to BC. So 2x is equal to BC minus BC dash, that is actually equal to CC dash. PC minus BC dash, that is equal to CC dash, and that is actually equal to y. So y is equal to 2x. So if we move this distance of the pulley by length of x, then the block attached to it, considering the fact that the other end is fixed, we must not forget this point that if one end is fixed and the pulley is moved by distance x, then this block moves a distance 2x. This we have to remember always. Actually, there is nothing to remember. It's pretty evident from the picture that this length up to this length everything is fixed. What's changing is actually this distance A dash and BB dash. So if it is x, it means 2x extra length of rope is here. So from where this 2x length came out? It must have came out from this position. It means that 2x distance has been covered by the block M if x is the distance being covered by the pulley. So y is equal to 2x. So if this use this y is equal to 2x, and if we differentiate it, what results comes out? The result is very simple, that if its velocity is v, then this velocity will be 2v, and more importantly, if its acceleration is a, this acceleration will be 2a at any instant. So if a force F is applied on a pulley such that it produces an acceleration a of pulley, then it means that in this particular situation acceleration of the block M will be 2a, because if we differentiate it, this 2 factor remains always, so it will come out to be in this way. Or if we double differentiate it, then acceleration of block comes out to be 2 into acceleration of pulley. But we must not forget, I am repeating, that this is possible only in this situation when one end of the string is fixed. So if this part is clear, we can come down to the question. And the question is actually very simple now, if this has been understood properly. That if a force F is applied on a pulley such that the block of the mass is M, then what will be the acceleration of this pulley? So this F is the force, so 2t is equal to F, which we discussed previously, that the F net on the pulley has to be 0, so t is equal to F by 2. So now we have to draw the FBD of this block M. So this block is pulled by only tension, there is no other force. Gravity is actually there, but gravity is not going to make any role here because the displacement is along x-axis. So when the displacement is along x-axis, gravity is perpendicular to it, so we have not need to consider gravity at all. We only need to take into consideration the horizontal forces, and that's actually just one force. So using Newton's equation, F net is equal to mass into acceleration. So the F net is equal to T, that is equal to M into A. Now T is equal to F by 2, so A is equal to F by 2M. So this is the acceleration of the block. So if someone asks what will be the acceleration of the pulley, very simple, as it is clear from the previous description that acceleration of block is 2 times acceleration of pulley. But I am repeating again and again that this is possible only in this situation when one end of the pulley of the string passing through the pulley is fixed. So acceleration of the pulley will be just F by 4m. As simple as that. So these were the 2 simple problems. In subsequent session we will discuss multiple body problems. Thank you.